surface, such as the sky or a whitewashed wall. However, this is not because looking at these objects would spur your eyes to produce floaters, but
So, hello, and I got some floaters in my eyes, and I said, it is the time to see what they really are, where they are coming from, and they're just flying around. What are these floaters? And then we are going to do coding.
rather because the floaters are more noticeable against a bright, uniform background. The consistency of such a monochrome backdrop makes it easier for us to distinguish a floater. Another reason for this is that in the face of a bright light source, your pupils contract. Remember the light wall shadow analogy I mentioned before? Now imagine what would happen if you change the brightness of the source of light. If the light is diffused, then your shadow would be equally diffused. However, a concentrated bright source of light would lead to a sharper shadow on the wall. A wide pupil is equivalent to a diffuse source of light, but when your pupil narrows to regulate the brightness of the uniform context in front of you, the shadows of the tiny objects in your eye become more distinct and thus more visible. Isn't it amazing how our minds can simply conjure up such wonderful illusions? Next time someone complains about the strange floating visions in their eyes, you can proudly claim that you know all about these curious little illusions of the human body. Also read, why does squinting at a light make a plus sign shape? Tags. Eye, medicine, pupil, retina, vision. Vaishnavi has a bachelor's degree in sociology/anthropology from St. Xavier's College, Mumbai, India, and is currently pursuing a master's degree in global studies, whatever that is, from Humboldt University.
Petrius. But I used to have them since I was a kid. Actually, now I have them less often. Anyways. So, floater exists, guys. If you have floaters, and you see things and they don't exist, don't think, wow, you have superpowers. You have superpower, but not for the floaters, for other stuff. This is something happens to everybody. They are not flying worms. Flying worms are butterflies. You know, butterflies used to be worms. Okay, let's go. So we have this code, and they want us to find, they say target is 5, you should find the index. If it is not in the list, just give us, the list is sorted where it should be. The difference is this time is that this class definition is different. Right, we always had class solution, and I was very strict about learning these headings. Now they have different. The reason is not that. What is this heading? I don't know. And this is advertisement. So what is the class solution? I got another one. There is a big one here. Class solution, public, int, research insert, search insert, vector, int, nums, int, target. I don't know how it works. What is public? What is this? Is it Python? Who is this, right? Yeah, it is me. Did I check for Python codes? Search and search, and it is oh, it is C++, I see. So we want the Python 3, okay. Back to normal. All good. Class solution, definition, search insert, self, noms, list, int, target, int. Noms list int, and when they say, okay, I remember when they say this list with the uppercase L, it means you should call a library. I don't know what library though. List int, target int. I have no clue. Okay, target is an int. But I don't get why we need to say list int. Anyways, that's good that we work with. It is very good to work with a new type of functions. Not functions. They are, what are they? Data. Data set. No, they are variables. Data storage. I don't know. Search, insert, self, noms, list, target, int. Okay, what I want to do. First of all, fuck complexity. Okay, the code wants us to do a program that solves the problem in O of log n, not O n. So we cannot say, okay, I want to search linearly in the you get it? I cannot say I want to search linearly and whenever I find it, I put my number right there in between. No. Okay, you should not see this. Okay. Now the problem is that we have a list. First of all, we don't know how to work with it, but it is later, right? And I want to make it a complete rectangle, bing, and these are our columns, right? So we cannot start and say, oh, okay, this is smaller, and here it is. No, this is ON, I guess. Because if you go all the way, we are going linearly, right? The way we want to do it is by a binary search, where we say, okay, probably we have like n-half and n-half, right? I remember this algorithm from high school. We have dogs here. kind of a dog was that? So here, like first we want to say what is happening in the middle. Are we bigger? Is the target larger than the middle or no? Okay. And we should take care if our list has an odd number of elements or even number of elements, then we compare it with the middle one. If it is larger, target is larger, we choose the second half of the list. If it is smaller, we go to the left side of the list. And that has a log2 exploration or search or whatever complexity. So one thing we need to again remember, actually I don't remember what should I import. For list I should import something, but for now let's just go hop into our, so we have class. We start class names by uppercase solution, and then we have the function. What is the name of the function? Search insert position, search insert. Then we have search insert, and I want to talk loud. Search, no, okay, for functions we don't start with an uppercase, it should be an lowercase. Don't fall camera. And search insert, what are the elements of the input arguments to the function? It is self, then it is the list. What is the nums? It's called nums, which is list of ints. Oh, we also had a code which was list of what was it? Strings. And we have the target, which is an int, and we are going to return int, right? I guess that's it. Right, for the indentation. I don't know, I got taller. What happened? Something happened. My head is going outside the frame. Every time I should fix this stuff. Just a bit is good. How is it now? It's better, I guess. Yeah. Yeah, I should better hunch. Int, and what are we doing here? First of all, I need to learn how to work with this n. Let the n be len of the list. Oh, nums. All right. How can we do the, what do they call it? Division? No. floor. Not floor, but we need floor, but yeah, it's floor. Fluorine, Python. Oh, we have floor and seal. All right. So if target is greater than, if target is greater than what if n is I think it works well. Floor of noms what noms? Oh, okay. Noms floor of bracket floor n over 2, right? If this happens, I want you, fuck. What should we return? Okay. Let me explain it here. Right? We want to solve the problem recursively. The thing is that we divide this list to 2 parts, right? And this is, for example, this index is floor n over 2, right? So we grab this part and we grab this part. This is as from 0 to floor n over 2 minus 1, right? And yeah, let's write it nice. This is 0. This is 0. This is, I called it n minus 1, right? This is floor n over 2, and this is floor n over 2 plus 1, right? Then we compare target, for example, with these elements, right? And we have this, for example, target is equal, less than, or bigger one of these two. Well, if it is equal, we just return the floor n over 2. If target is bigger, we should look at this second half. And if the target is smaller, we are looking at this first half, right? The thing is that we bisected the whole list. Now, for example, if I am looking in the second part, I want to give it as an input to my function again to work in a recursive manner, right? So what should I do is I need to keep track of the indexes here, because the index in this list, it starts here. It used to be floor n over 2 plus 1, and now it shifts to 0 in this new one. And if it is, this one will be n minus 1 minus floor n over 2 minus 1, right? But this part will be the same. Okay. What are we going to return? We are going to return we are going to return search what was the number? Okay, it was 0. Whatever it is, we should add it plus floor n over 2 plus 1 plus search insert search insert of what is nums? It will be nums from floor n over 2 plus 1 up to n minus 1. And target. Okay. If target is less than is return. What are we going? We are just going to return the index of the first part. 0, 2, floor n over 2. Right, and actually this should be n, because remember the closing index is not inclusive in Python, so this should also be plus 1. Don't fuck. And if target equals you just return the index, right? Okay, one problem is that what if we don't have it, right? We should check, because it is possible that the target is not in the list. Not. This one only says where the index should be. But it's all okay. I think it still works, right? We may end up in a situation. What are the situations that we end up at the end of this recursive method, right? If the target is not in the, if it is in the list, well, we are happy, we find it. But if it is not, what are the final situations? Let's see. Like when our list gets very small. Like we may have a list of 3, we may have a list of size 2, right? That's it. Yeah. Can we have a list of size 1? Not really. So when the list gets very small, we can say what is the index, and it's not a big deal at all. Right, we have a list of size 4, we will break it into 2 of size 2. So that's it. And we have 3. Actually, yeah, that's it. If it is 5, it will be a 3 and a 2. So what will we do with the 3 is that 0, 1, 2, we break it in, what is n? N is 2 here, right? N is 2. Yes, n is 2. N over 2 is 1. So we have 1 is from, okay, it may even cause us some problem here. So n is 2. 2 over 2. 1. Okay. I feel it's fine. Either way, right? I feel it is fine either way, right? Yeah, once n is less than 3, I'm okay to do this by hand. If n is 3, We should just return the index, right? Or we should. That's right. Okay. So n is 2. Wait, is it possible that target is less than minimum of the nouns? Yeah, it is possible. So, okay. So we only are studying cases where n is less than 1. Okay, no, the recursive part is only for n greater than equal 3. So when we say 3,